हेलो। मोशन चैप्टर में जब हमने ग्राफिकल रिप्रेजेंटेशन ऑफ मोशन पढ़ा था तो उसमें हमने एस टी ग्राफ, वी टी ग्राफ और ए टी ग्राफ पढ़े थे। यहाँ पे मैं ग्राफ पे ही थोड़ा सा और आगे आपको बताऊंगा। इस समय डायरेक्टली मोशन पे बेस्ड नहीं है। नाउ फॉर इंडिपेंडेंट ग्राफ, इफ वाई इज इंडिपेंडेंट ऑफ एक्स, so whatever be the value of x, y will not change. So if initially it was here, so it remain at this position. Actually y is not increasing, it is x increasing, y is at its position. So for independent graph can be like this, it can be like this also. Let us suppose y is 0, it is independent of x, so whatever be the value of x, it will remain y. And third possibility, if it is negative, oh sorry. So now for rest position, it resembles with the case for rest position, ST graph rest position. So if I would change this as S displacement, and it is, so for rest position, if its initial position was somewhere here, so with increase in time it will remain same. And if it was at origin, I mean it was initially at 0 distance from our point of observation, so with change in time it will remain at 0 position. And in the same way, if with reference to our reference point, it was at a negative position, so it will remain at that negative position. In the same way, it can be this is for rest position, stationary position. Okay, so in the same way, there can be a condition of constant velocity. So for constant velocity or uniform motion, it is like this. This is for constant velocity, uniform motion. So for uniform motion, velocity does not depend upon time because velocity is constant. So we can say independent graph of something which is independent of that other factor which we are including. Oh, it is looking like it is not the case of uniform motion. It is the case of stationary or rest position. This is only the case. Otherwise, these two are for uniform motion because velocity remains constant, either positive or negative. And this is also constant, but it is zero velocity, and zero velocity means it is at rest position. Now, directly proportional graph. So y is directly proportional to x. Then there is possibilities. This one, y is directly proportional to x. Okay, there are certain conditions in which it is in the form of an equation, then it can be like this also, and it can be like this also. So this is for positive slope. For negative slope, it will go downward. Now, this is directly related for y proportional to x. Or if we replace this proportionality sign, we can write it. This is y proportional to x. So when we replace this proportionality sign with some constant will come here. And here, y equal to cx and some other constant for this addition. And here, y equal to cx minus k for this subtraction. So in mathematics, these are called intercepts. So this is positive intercept, this is negative intercept. So these are also called equation of a straight line, y equal to mx plus c. So there they write it like y equal to mx. M is called slope of that graph, or plus some constant. That constant it is intercept, like k is here. This is the value of k, negative of course. This is k, positive, of course. There is no k because it is 0. Now, okay, so on the basis of this, we have some certain graph based upon this. Like first, we will deal this. So if I am writing here ST graph for constant velocity or uniform motion. Uniform motion means velocity remains constant. And if you could remember, for ST graph, velocity was the slope of the graph. So here slope is constant, that is velocity is constant. This is the one thing. Second thing, it is starting from somewhere here on the upper side. All right, so this for uniform motion. It can be this also, and it can be this also. So we'll not write it like y equal to this thing. In fact, this also, we will write it s equal to something, some constant into t. What is that constant? Has it some physical significance? Think about it. Here also, s equal to that something and plus some constant. Double T, constant. All right, so here also s equal to that something, t plus some constant. All right, y equal to mx plus c, where m is called slope. And what is the slope of ST graph? It is velocity. So s equal to vt, isn't it? Displacement equal to velocity into time, or distance equal to speed into time. So here velocity is constant. So these are the graphs for uniform motion. Velocity is constant. Similarly here, okay, we haven't gone through such kind of equation till now, but you can think something about this. S plus S naught. S naught is some initial position. Let us suppose race has to be started from this point and someone is running from here. So this is the part that person is taking extra. So if we are observing from here and body starts from here, so this distance will be called S naught, and then overall distance will be Vt plus this S naught. And in the same way, this one, oh sorry, not plus, actually minus. So minus will come because of this negative sign. So Vt minus S naught, that S naught. Here positive S naught, here negative S naught. So actually this is plus constant, and plus constant here it has minus value, so minus that constant value. In the same way, we can have velocity time graph also. But for velocity time graph, proportionality, if v is proportional to t, in this case, velocity is equal to some constant into t. Now, what is that constant is all about? Think about it. And this is not the case of uniform motion because velocity is changing. So once again, I'll write velocity equal to some constant plus constant into t plus some other constant. Here also, v equal to some proportionality constant and minus some other constant. All right, so we know for because once again y equal to mx plus c. This is the formula for straight line. So here the slope, m is slope, and v equal to some slope t. For vt graph, slope is acceleration. This is the case when initial velocity is 0. Now here once again at and some, oh sorry, this is now v, actually here also v. So some initial velocity, and that initial velocity we know it is called u. So it is u. So v equal to u plus at. And in the same way, it is also possible that initially, due to our point of reference, initial velocity is negative. So what we will do, at minus u. So this is how graphs are related. All right, so now third one, y is directly proportional to x square. For independent graph, it is a parallel line. For directly proportional, it is a slant line. It can pass through origin, it can pass through with positive intercept, it can pass through with negative intercept. Now, y proportional to x square. So there's not much space. I'm skipping it. I'm skipping that cube part. And yeah, I will tell you about that in other part. Right now, I want to just tell you how what is the difference between these two, and what is their difference with this third case. So y equal to x square. It is y, it is x. Now y proportional to x square, it is actually if we change it, remove proportionality sign, so it will become some constant c x square. Now in this case, what will happen, this c, and this is the proportionality constant. Now there are two variables, and it is a quadratic equation with two variables. It is not that quadratic equation in which we have this x square plus x square x square plus x and plus something equal to 0. It is not that kind of quadratic equation. It is a quadratic equation where we have two different variables. So y and other one is x, and x has some power. Vice versa can also be happen. I mean, x equal to cy square can also be possible, but ultimately there are two variables, and one of them has one power, other one has two power. So here graph will go like this. Why it is happening, I will tell you later. There is second option also, some constant x square, some positive intercept. And in the same way, y equal to cx square and minus k. So here, oh sorry, graph line is not properly visible. This is much better. So it will go from bit negative side, and this is the negative intercept. So all these three graphs are possible for this parabolic kind of graph. All right, so if you could remember that for uniformly accelerated motion, we have drawn a graph like this. At that time, I told you that it can go from origin, it can go a bit above from origin or below the origin. So these are ST graph for uniformly accelerated motion. Now, we know that for uniformly accelerated motion, equation goes like this: s equal to ut plus half at square. So actually, so here you people can say that this graph doesn't meet the requirement of this equation. So I told you that it should be a quadratic equation with two variables, in which one variable should have one power, maximum power 1, and other should have maximum power 2. So this is possible that it can have a term with single power. So one power, 2 power. So it is totally accepted. Here there will be a change. So change will be s equal to some s naught plus ut plus half at square. And here we can have s equal to minus s naught. So we can say s plus s naught. Oh, it can bring a confusion. So I'm writing it s equal to minus s naught plus ut plus half at square. So if initial velocity is 0, then directly this requirement holds good. This formula holds good. But if there is initial velocity, we have to put that. So that will make a certain adjustment in the graph. Not so much. So will be a slight adjustment, but nature of the graph will be parabolic always, if there is a term with power 2. So remember this thing with independent, parallel, direct proportion, slope, slant. It can go from origin or above it or below it. And proportional to x square, then it will be parabolic. Now, that part where y I told you that y is directly proportional to, initially I wrote that y is directly proportional to x cube. So in this case, if power goes on increasing, so the curveness of the graph goes on increasing. So if this is the graph for y proportional to x square, so for x cube it will be much steeper, y proportional to x cube. If you could remember that nowadays in corona pandemic, in many countries graph is rising like this cases. So actually they are calling it exponential graph. That is a different thing, but its nature is somewhat this form. With the power with increase, if there is a power in other factor, so it will turn steeper and steeper. So nowadays you might have noticed, and in the same way there is another kind of graph in which there is a flattening. We will discuss about it later. Now we have done all of these for direct proportional. Now I will tell you something about inverse proportion. But before that, an important thing also I want to tell you that if you find an equation in this form, x square plus y square, both variable, it was parabolic, but here if you find x square plus y square equal to some constant square, if you find something like this, there can be some x term, there can be some y term also in addition. But if maximum power of x is x square, maximum power of y is y square, and there is some other term, then this represent a circle. And if instead of okay, there can be there is same factor here, 1 1. There can be 2 2 also, but we can take both of them common and put it here, and some constant square. So ultimately it is reducible to x square plus y square. But if it is not like this, it is something like a x square plus b y square and then equal to some constant or constant square, whatever, then such kind of equation represent ellipse. Uh, Actually, these are not directly in your syllabus right now in physics, but in mathematics they are so important. And for the if we talk about competitive exams, so they can give such kind of equation for certain motion, and they can give option whether it represent a straight line motion or whatever. And if there is an option for circle and this equation is given, you can take this, and ellipse, so this equation you can take. So you need to just have general idea about this. Now in this case, y is inversely proportional to x. So it's so important graph. So in upcoming topics, such kind of inverse relation also important, and their graphical question will be asked. So y inversely proportional to x. Now what happens for inverse proportion graph? This kind of graph neither touches x-axis nor touches y-axis. So it goes like this. So briefly I will tell you, like if I could put x equal to 0 here, so y will be equal to some constant c into 1 by x. So if x equal to 0, y will be equal to infinity, and if x equal to infinity, y will be equal to 0. So at infinity level, these graph will meet x-axis and y-axis. This is the inverse. So this looks like parabolic graph, but it is not a parabola. However, it is also called hyperbola. Here, now what will happen? Actually, right now I don't have any example, because right now all the equation which we have studied do not depend upon such kind of inverse relation. However, if you could remember, like f equal to g m upon r square, if you could remember this formula, sorry, this formula relates here, x square r square. So so first I will draw this here. As I told you earlier, like y directly proportional to x square and then x cube. So I said that it will go steeper. Now here it will become more curve. So initially the curve was this for y is inversely proportional to x. Now for y inversely proportional to x square, it will become more curve. And in the same way, y inversely proportional to x cube, actually not in our use, but you have to remember this. If this is proportional to x, this is proportional to x square, so it will go much curved for x cube. I mean, there is not a clear-cut distinction between these three graphs, but in comparison with each other, we can clearly say that if it is less curved, it is proportional to x or some lesser powers, and greater power will curve more. So here, like here, so as I told you, so if I want to draw graph between f and r, so that will go like this. Here I can tell you a graph like f equal to ma. So a equal to f by m means acceleration in a body is inversely proportional to its mass for a given constant force. So if I want to draw a graph between acceleration and mass for constant force, so it will go like this. For very less massive object, acceleration is too high. For very massive object, acceleration is much lesser. I hope these things are clear to you. Some other graphs. Now these are exponential graphs. It's a quite new term for class 11th students. In maths, this term will come. It is called exponential. This E is not electronic charge, but it is exponential term. And this e to the power x means 1 plus x upon factorial 1 plus x square upon factorial 2 plus x cube upon factorial 3 up to so on, where this factorial notation means like if factorial 3 I want to write, so it will be written as 3 into 2 into 1. So but interestingly 0 factorial is equal to 1. So I'm not going into deep in it. Actually, factorial, it is a casual notation, like factorial 3 is 3 into 2 into 1. Actually, higher mathematics um, uh, has its proper explanation. So I will make a separate video upon these factorial notation also. It is totally mathematical part. So we'll discuss about it later. Right now, we'll focus on this. So if minus x, so replace all the x terms with negative sign. So this will become negative. This will be the positive, negative, and alternate order will go. So how will this graph behave? Here y, here x. So if I would place x equal to 0, so in the place of 0, e to the power 0 is 1. So this graph will, okay, one thing is also there. I have to write it in proportionality notation. So because in order where this graph line will pass, that depends upon those constants also. So in case, and this is directly e equal to some constant and then e to the power. All right, so it is exponential graph. This is positive, this is negative. So exponential positive growth. So it is similar to that parabolic graph, but both are different. In parabolic graph, there is an increase in slope, a gradual increase. And with the increase of power, it goes on increasing. But exponential is a sudden increase. Each time it just multiplicate itself. So that is why it is this kind of nature. And for negative graph, it will have initial some value and then it will goes on decreasing. So it ends at infinity and it ends at 0. So when here, when x tends to infinity, y also tends to infinity. And here, if x tends to infinity, y tends to 0. This is the difference between these graphs. There are some other graphs also. One is sinusoidal graph. Now, for sinusoidal graph, all right, sinusoidal graph. So if y equal to some constant sine x and y equal to a cos x, is some constant, as usual, as I am telling you earlier. So now what happens if x is here, y is here? So value of sine, where is here x will represent, because the sine is associated with angle only. So x has value of some angle. So here 0 degree, 90 degree, 180 degree, 270 degree, and 360 degree. Actually, now instead of writing it in degrees, we will use radian. So actually 180 degree is equal to pi radian. So that is 90 degree is equal to pi by 2 radian, and so on. I mean, 1 degree is equal to pi by 180 radian. So remember this thing, and this will be helpful in upcoming topics also. So this is pi by 2, this is pi, this is 3 pi by 2, this is 4 pi by 2 actually, that is 2 pi. Now how this graph goes, now remember these points, I'm going to wipe out them. So it goes like this, maximum value, positive value, and on other side negative maximum. So it is a, it is minus a. Now remember one thing, sine 90 is 1 and sine 180 is 0. Sine 270 is minus 1, and sine 360 is again 0. Its graph, and its graph goes on a curve manner. So it goes like this: maximum on 90, this is for 90 mark, this is for 180 as I mentioned earlier, and for 270 it goes downward for negative peak, and 360. So it is called sinusoidal function. Its value, it is not like this, rather it has a curve nature, and here at it is 1 multiplied by a, so that is why a it is. So this is, and it will go on and on and on. For cos, you know that cos 0 is 1. So in this graph things change, like it starts from here. So this is 90, pi by 2, pi, 3 pi by 2, and 2 pi. Here I can mention now pi by 2, pi, 3 pi by 2, and 2 pi. Here also, but I will draw them later on. So it will go like this. Okay, so by this you can also remember how sine function changes from 0 to pi by 2, it remains positive, then pi by 2 to pi, it again remains positive, then pi to 3 pi by 2, it becomes negative, and 3 pi by 2 to pi, it remains negative. And here for cos function, 0 to 90, it remains positive, then it remains negative, again it becomes negative, then remains negative, and then becomes positive. On the basis of that, you can memorize value of sine also, and I know that you people know it, but still a quick summary. So on the basis of this graph, we can remember all these values. So you people might know this. First write 0, 1, 2, 3, 4, then divide all of them by 4, then take root of all of it. First becomes 0, second becomes 1 by 4, so its root, okay, I'm writing it like this, and root 1 by 4, here it will get cancelled, 1 by 2 here, 3 by 4, and 4 by 4, that is 1. And after taking root, it will become 0, it will become 1 by 2, it will become 1 by root 2, it will become root 3 by 2, and it is 1. So put the values here: 0, 1 by 2, 1 by root 2, root 3 by 2, and 1. And now reverse it, because it is symmetrically going down. So just mirror image 3 by 2. Just excuse me for those background noises, but it is some workshop where they have given me some space. So because right now I'm in Uttarakhand and just spending time in this pandemic. All right, now once again on this is also like this one varying, so also this is varying, but in negative sense. So this will go here with negative sign, this will go here with negative sign, this will go here with negative sign, and this will go here with negative sign. So sine 270 is -1. And now for 300, again again a mirror image for each of it. So its mirror image will go here with a negative sign, root 3 by 2, then minus 1 by root 2, and then minus 1 by 2, and again 0. On the same way, in the same way, we can do it for cos 1 and root 3 by 2, 1 by root 2, 1 by 2, and 0. But for cos now, all the values will be negative. So just put the mirror image of these with negative sign, and minus 1 by root 2, minus root 3 by 2, and minus 1. And again, negative, all the values are negative. So just we have to flip these with their sign. Minus 3 by 2, minus 1 by root 2, minus 1 by 2, and then 0. And once again it will rise now. So how will it rise? All these values with positive sign, just flip them. Now 1 by root 2, root 3 by 2, and 1. In the same way, you can find other values also. Graph for tan is also interesting. I'm not drawing right now. It actually video is going too lengthy because of that. So these are the graphs, and on the basis of these, we can just understand motion and other topics in physics. So here I am putting a question in front of you, and maybe in next video I will give it solution. V square equal to u square plus 2as. Try to draw graph between v and s. So I'll give you a hint. First put s equal to 0, then just estimate where all other point will lie, and on the basis of that you can draw this graph. So that's all for today. Thanks for watching.